Time travel. It's a concept that has captivated our imaginations for centuries. From H.G. Wells' The Time Machine to the adventures of Doctor Who, we have been enthralled by stories of journeys through time. Science fiction writers have envisioned intricate machines and portals that allow characters to leap across decades or even millennia. But is time travel truly confined to the realm of fiction, or could it one day become a reality? As a scientist, I find myself drawn to the scientific possibilities that underpin these fantastical tales. While we may not be hopping into DeLoreans just yet, the laws of physics do not entirely rule out the potential for time travel. In the vast universe we inhabit, governed by the principles of physics, there exist theoretical pathways that suggest time travel might be more than just a flight of fancy. In this exploration, we will delve into the intriguing realm of time travel. We will examine the scientific concepts that hint at its possibility, the challenges that lie in our path, and the tantalizing potential it holds for the future. Our journey begins with a revolutionary theory that reshaped our understanding of the cosmos: Albert Einstein's theory of relativity. Before we can dive into the complexities of time travel, we need to grasp the fundamental principles that govern the universe. This is where Albert Einstein enters the picture. At the beginning of the 20th century, Einstein revolutionized our understanding of space and time with his groundbreaking theory of relativity. This theory, often perceived as daunting and complex, can be distilled into a beautifully elegant concept. Imagine a vast four-dimensional fabric. This fabric, known as space-time, represents the interconnectedness of space and time. Objects with mass, such as stars and planets, create curves in this fabric, much like a bowling ball placed on a trampoline. These curves are what we perceive as gravity. Now here's where it gets interesting for aspiring time travelers. Einstein's theory suggests that time is not absolute but rather relative. This means that time can be stretched and compressed by gravity and motion. The stronger the gravitational pull or the faster an object moves, the slower time passes for that object relative to a stationary observer. This phenomenon, known as time dilation, is a key ingredient in the recipe for potential time travel. It suggests that time is not a rigid, unchanging entity, but rather a fluid aspect of the cosmos that can be manipulated under the right circumstances. Time dilation, the stretching of time due to gravity or motion, opens up intriguing possibilities for journeys into the future. Imagine a high-speed spaceship, traveling at a significant fraction of the speed of light. According to Einstein's theory, time would pass slower for the astronauts on board the spaceship compared to people on Earth. Let's say the spaceship embarks on a journey at 99% the speed of light. For every year that passes for the astronauts on board, decades could pass on Earth. Upon their return, the astronauts would find themselves in Earth's future, having effectively time traveled. While achieving such speeds is currently beyond our technological capabilities, the concept of time dilation is not merely theoretical, it has been experimentally verified using atomic clocks. These incredibly precise timekeepers have shown that time does indeed pass slower at higher speeds and in stronger gravitational fields. Atomic clocks, the most accurate timekeepers ever created, provide compelling evidence that time dilation is a real phenomenon. These sophisticated instruments can measure time with astonishing precision, detecting even the slightest variations caused by differences in gravity or motion. In one experiment, scientists flew atomic clocks on airplanes around the world. When compared to synchronized atomic clocks on the ground, the clocks on the airplanes showed a slight but measurable time difference. The clocks on the airplanes had ticked slightly slower due to their motion relative to the clocks on Earth, confirming Einstein's predictions. These experiments, while demonstrating time differences on a minuscule scale, provide concrete evidence that time dilation is a real phenomenon. They also offer a glimpse into the possibility of more significant time travel to the future, should we be able to achieve speeds closer to the speed of light. Section 5. Wormholes, bridges through space and time. Traveling to the future, while theoretically plausible, presents a significant challenge, achieving the immense speeds required for noticeable time dilation. But what about traveling to the past? This is where things get even more complicated, and we venture into the realm of theoretical objects known as wormholes. Imagine space-time as a sheet of paper. Now fold the paper in half so that 2 points on opposite ends touch. This fold represents a wormhole, a hypothetical shortcut through space-time that could connect distant points in space and time. Theoretically, by traversing a wormhole, one could emerge at a different point in space and time, potentially in the past. However, the existence of wormholes remains purely theoretical, and there is currently no evidence to suggest that they exist in nature. Section 6. A wrinkle in time. The challenges of creating and navigating wormholes. While the concept of wormholes is captivating, The practicalities of utilizing them for time travel are fraught with challenges. First and foremost, creating a wormhole would require an immense amount of energy, far beyond our current technological capabilities. Some physicists speculate that wormholes might require exotic matter with negative energy density, a concept that remains hypothetical. Furthermore, even if we could create a wormhole, navigating it safely would be another hurdle. The stability of wormholes is questionable, and they might collapse upon themselves, potentially crushing anything attempting to pass through. The challenges of harnessing wormholes for time travel are immense, bordering on insurmountable, at least with our current understanding of physics. However, the possibility, however remote, continues to fuel scientific inquiry and imagination. Section 7. The Grandfather Paradox. Unraveling the complications of time travel. The prospect of traveling to the past raises a host of perplexing paradoxes that have puzzled philosophers and physicists alike. One of the most famous is the Grandfather Paradox, a thought experiment that highlights the potential logical inconsistencies of time travel to the past. Imagine you could travel back in time and meet your grandfather before he had children. Now, suppose you were to prevent your grandfather from meeting your grandmother, perhaps by accidentally causing him harm. This action would alter the course of history, preventing your parents' existence and consequently, your own. If you were never born, how could you have traveled back in time to prevent your grandfather from meeting your grandmother in the first place? This paradox highlights the potential contradictions and logical inconsistencies that arise when we contemplate altering the past. Section 8. Beyond the Paradox, Exploring Potential Solutions and Interpretations. The Grandfather Paradox and other time travel paradoxes have spurred numerous attempts to reconcile the possibility of time travel with our understanding of causality and logic. Some physicists propose that time travel to the past might not allow for changes to the timeline, suggesting a self-correcting mechanism that prevents paradoxes. One interpretation is the Novikov self-consistency principle, which posits that any actions taken by a time traveler in the past were always meant to happen and are already factored into the fabric of space-time. This principle suggests that while you might be able to visit the past, you wouldn't be able to change it in any meaningful way. Another interpretation suggests that time travel to the past might lead to the creation of parallel universes, each with its own distinct timeline. In this scenario, altering the past wouldn't change your original timeline but rather create a new branch of reality. Section 9. The Quest for Time Travel. Current Research and Future Technologies. While time travel remains firmly in the realm of speculation, scientists continue to explore the boundaries of physics, searching for clues that might one day unlock the secrets of time. Research into exotic matter, wormholes, and the manipulation of space-time is ongoing, driven by a thirst for knowledge and the desire to push the boundaries of human understanding. Advancements in quantum physics in particular offer tantalizing possibilities. Quantum entanglement, a phenomenon where two particles become linked and share the same fate, even when separated by vast distances, hints at the interconnectedness of space-time in ways we are only beginning to comprehend. As technology advances, we may develop new tools and techniques that could potentially manipulate gravity, create wormholes, or harness the power of quantum phenomena to unlock the secrets of time travel. While such advancements are purely speculative at this point, the pursuit of knowledge often leads to unexpected breakthroughs. Section 10. The Allure of the Unknown. The enduring fascination with time travel. Time travel, with its paradoxes, possibilities, and mind-bending implications, continues to captivate our imaginations. It represents the ultimate frontier, a tantalizing glimpse into the unknown that challenges our perceptions of reality, causality, and the nature of time itself. The human desire to explore the past and glimpse into the future is deeply ingrained in our psyche. It's a testament to our curiosity, our thirst for adventure, and our yearning to unravel the mysteries of the universe. Whether time travel ever becomes a reality or remains a captivating concept confined to the realms of science fiction, the pursuit of this dream continues to inspire scientific exploration, philosophical debate, and our collective fascination with the cosmos and our place within it. Section 11. Time travel, a possibility that ignites our imagination. As we conclude our exploration of time travel, we find ourselves at the intersection of science, imagination, and the boundless possibilities of the universe. While the scientific hurdles to achieving time travel, particularly to the past, remain daunting, the very concept continues to fuel our sense of wonder and drive our quest to comprehend the cosmos. The laws of physics as we currently understand them do not entirely rule out the possibility of time travel. Time dilation, a consequence of Einstein's theory of relativity, has been experimentally verified, highlighting the malleable nature of time. While wormholes and other theoretical concepts remain speculative, they offer tantalizing glimpses into potential pathways that could one day unlock the secrets of navigating time. The journey of scientific discovery is often paved with unexpected twists and turns. What seems impossible today might become the breakthrough of tomorrow. The pursuit of knowledge fueled by curiosity and imagination is what propels us forward, expanding the boundaries of human understanding and revealing the wonders of the universe. Time travel, regardless of its feasibility, serves as a powerful reminder of the vast unknown that lies ahead, beckoning us to explore, question, and dream of what might be possible.